Okay, we'll start at 8 o'clock in about 3 minutes. Brianna, is that you? And Scott and
Yes.
Damon. We'll start in about a minute. Your email finally showed up.
Oh,
Or did you try to send it again?
I did not try to send it again.
It showed up, Saturday sometime.
I did say that, it didn't say about my house, because I sent it about 5 times, and I saw it also, my phone goes ding, 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 ding. So I got one now. Thank you for
Yeah.
allowing me to bring it in.
All right, it's finally 8 o'clock. We'll be in section 4.1 again, solving systems of linear equations, and we'll solve them by substitution and addition. The addition method is also called elimination. So some things that we've already discussed, we'll go over briefly. A solution to a system of 2 linear equations in the variables x and y is an ordered pair, x comma y in parentheses, that satisfies the conditions of both equations. Another way to say the same thing is a solution to a system of 2 linear equations is a point on each line. And graphically, a solution to a system of 2 linear equations is a point where the 2 lines intersect. We say that a system of 2 linear equations is consistent if it has at least one solution. And if there is no solution, then the system is inconsistent. Okay, remember this statement. If you have a system of 2 linear equations, then 1 out of 3 things will occur. There will be exactly one solution, or infinitely many solutions, or no solution. one of those three things has to occur in a system of two linear equations. Okay, here are a couple of examples, and I'll show you how to solve the systems by substitution. Okay, so this first one, one of the equations is negative x plus 4y equals 8. And the other equation is 2x plus 4y equals negative 4. When solving by substitution, we have choices. We can pick one of the variables in either of the two equations and solve for that variable. So we have four choices. So I can pick x in the top equation and solve that equation for x. And if I do that, then I'm going to replace the x in the other equation with what I found x to be equal to from the top equation. That's one option. A second option is to solve the top equation for y, so I get y equals something. And then in the other equation, replace y with what I found y to be equal to in the first equation. That's the second option. The two other options are, the third option, solve the second equation for x and then replace x in the first equation with what x is equal to from the bottom equation. And the fourth option, solve the bottom equation for 4y. Solve the bottom equation for y, and then after solving for y in the bottom equation, replace y in the top equation with what y is equal to from the bottom equation. Those are four options, and there are even other options that experience will reveal. I'll just mention it here. If I solve the top equation for 4y, notice the bottom equation has 4y in it. So if I solve the top equation for 4y, I can just replace 4y in the other equation with what 4y is equal to from the top equation. So many options, but usually you can identify what variable might be easier to solve for. So it looks like if I solve the top equation for x, that's not too bad. I'll solve the top equation for x. So the first thing is subtract 4y from both sides. So I get negative x equals negative 4y plus 8. And then divide both sides, every term on both sides of the equation by negative 1, because I'm solving for x. And I get x equals 4y minus 8. Okay, now in the bottom equation, I'm going to replace x with 4y minus 8. So this is the substitution step. So the bottom equation has 2x plus 4y equals negative 4, but I'm going to replace x with 4y minus 8. And then write everything else. Now we solve this equation for y. So we distribute multiplication by 2. We get 8y minus 16 plus 4y equals negative 4. In the next step, I'll do two things at once. I'll combine 8y plus 4y and also add 16 to both sides. So 8y plus 4y is 12y. I'll go ahead and put in the extra step. So if I just write 12y minus 16, and now we can add 16 to both sides. So we get 12y equals negative 4 plus 16, so 12y equals 12. And then divide both sides by 12, we get y equals 1. So this tells us that the y-coordinate of the solution is 1, and to find the x-coordinate, we go back to what x is equal to and substitute y with 1, so x is equal to 4 times 1 minus 8. 4 minus 8 is negative 4. And so the solution to the system is the ordered pair. The solution is the ordered pair xy. The x-coordinate is negative 4, and the y-coordinate is positive 1. That's the solution to the system. What does that mean graphically? That means that if we graph the two lines, they will intersect at the point negative 4, 1. But solving by graphing is precarious when it's up to us to draw the graphs. If you have a computer program that will graph the lines for you, then that's usually a better result if you're going to solve by graphing. Okay, let's solve the next system of two equations by substitution. So we can choose to solve the top equation for x, or we can solve the top equation for y. If you don't like those two choices, we can solve the bottom equation for x, or solve the bottom equation for y. We have those four choices. And then there are more sophisticated ways to use the substitution principle. I think I'm going to solve the top equation for y. So solve for y. You can choose to do it a different way if you want. If I solve the top equation for y, first thing to do is add 3x to both sides. So I get negative 3y equals positive 3y plus 6. Then divide every term on both sides by negative 3. That's supposed to be plus 3x. Divide every term on both sides by 3, negative 3. Negative 3y divided by negative 3 is y. 3x divided by negative 3 is negative 1x, or just negative x. And then 6 divided by negative 3 is negative 2, so I write y equals negative x minus 2. Okay, now in the bottom equation, this is the substitution step. In the bottom equation, we're going to replace y with what y is equal to. Y is equal to negative x minus 2 from the top equation. So I'll make a note, replace y in the bottom equation with negative x minus 2. Okay, so when we do that, we get negative x plus 3 times, we're going to replace y with that quantity, negative x minus 2. And now we solve this equation for x. So algebra and arithmetic, negative x, and then plus 3 times negative x, that's equivalent to minus 3x. And then minus 3 times 2 is minus 6, equals 18. we'll combine like terms. Negative x minus 3x is negative 4x. And so negative 4x minus 6 equals 18. Now add 6 to both sides. We get negative 4x equals 24. Then divide both sides by negative 4. X is equal to negative 6. Okay, so the x-coordinate of the solution is negative 6. To find the y-coordinate, we go back to this equation, and this time we're going to replace x with negative 6. So we get y equals the negative of negative 6 minus 2. The negative of negative 6 is positive 6, and 6 minus 2 is 4. Okay, so the solution, I'll write x comma y in parentheses, just as a reminder that the solution is the ordered pair xy. We found x to be negative 6 and y to be 4. So the ordered pair negative 6, 4 is the solution to the system. If you're ever in doubt about your solution, you can always check it in the original system of two equations. So we did that a couple of times. So for example, in the top equation, you can replace x with negative 6, replace y with positive 4, and then check that the resulting equation is true. You can almost do that visually. Right? Negative 3 times negative 6 is positive 18, and 18 minus 3 times the y-coordinate 4, so 18 minus 12 equals 6. That's true. And while we're at it, we might as well check that negative 6, 4 is a point on the bottom line. Replace x with negative 6, so the negative of negative 6 is 6. And then plus 3 times 4 is 12, so 6 plus 12 equals 18. So everything checks out. We verified that negative 6, 4 is a solution to the system. Okay, the next few examples will solve systems of equations by the addition method, which is also called the elimination method. The addition method means we're going to, at some point, we're going to add the equations. But we want to add them so that one of the variables is eliminated from the addition. So you can, after you've seen this done a couple of times, you can see why both of those terms are used, the addition method or the elimination method. In this system's current state, if we add the two equations, nothing is eliminated. Okay, but it's legal to add two equations. You'll just get another equation. So if you were to add these two equations, the left-hand side would become 4x plus y, and the right-hand side would become 20 if you add the two equations. You see that? Negative 4x plus 8x is 4x. 3y plus negative 2y is just y. So the left-hand side is 4x plus y. And the right-hand side, 16 plus 4 is 20. But neither of the variables was eliminated. So we have to do some preliminary work in order to get an elimination. So to get an elimination by adding two equations means we're going to pick one of the variables and we're going to write down equivalent equations so that in the variable that we choose to eliminate, the coefficients are negatives of each other. So let's focus, in this case, let's focus on the variable x. In the top equation, the coefficient is -4 for x, and in the bottom equation, the coefficient is 8. If I multiply both sides of the top equation by 2, and that's legal, I can multiply both sides of an equation by a non-zero number. If I multiply both sides of the top equation by 2, the x term will become -8x. And -8 is the negative of +8. And if I add -8x to 8x, I get 0, which means the variable x will be eliminated. Okay, so on this one, even though we have multiple options, one of the easier things to do is multiply every term on both sides of the top equation by 2. So I'll just make a little note here. Multiply by 2, by which I mean multiply every term on both sides by 2. And the left-hand side becomes -8x plus 6y. And the right-hand side multiplied by 2 is 32. And I'm going to leave the bottom equation the way it is. So it's just 8x minus 2y equals 4. And now when I add these two equations, we'll get an elimination. The variable x will be eliminated. Okay, so we add the equations. -8x plus 8x is 0. 6y plus -2y is positive 4y. On the right-hand side, 32 plus 4 is 36. And then if 4y equals 36, divide both sides by 4, y equals 9. Okay, so now we've found the y-coordinate of the solution. Now we have to find the x-coordinate. We could set up another system and use the addition method again, but usually the easiest thing to do, once you found what the value of one of the variables is, you can just use substitution in either of the original equations and then solve for x. In fact, you can use any one of those 4 equations. Well, this one is the same as that one. You can use any one of those 3 equations, replace y with 9 and solve for x. That will give you the x-coordinate of the solution. Okay, so you get to pick. I'm going to pick the bottom equation. And the fact that y equals 9. So in the bottom equation, I'm going to replace y with 9. So I get 8x minus 2 times 9 equals 4. Minus 2 times 9 is minus 18. And then we solve for x. Add 18 to both sides. 8x equals 22. Divide both sides by 8. X equals 22 over 8, or 11 over 4. Okay, so the solution to the system of 2 equations is the ordered pair xy equals 11/4 for x and 9 for y. That's the solution. Graphically, that means that if you were to graph the two lines, the point where they intersect is the ordered pair 11/4, 9. That's where the two lines intersect. Okay, the second system here, 7x minus 3y equals 8, and negative 14x plus 6y equals negative 16. So let's use the addition method again, also called elimination. So we always have multiple choices. So notice if we look at the variable x, in the top equation, the coefficient of x is 7, and in the bottom equation, the coefficient is negative 14. So one option is to multiply every term on both sides of the top equation by 2 again, just like we did in the previous example. Because if we multiply every term on both sides of the top equation, 7x times 2 is 14x, and 14x plus negative 14x is 0. So that would give us an elimination. But I want to do something a little different. Notice in the bottom equation, every coefficient and constant is an even number. So if I divide every term on both sides of the bottom equation by 2, then the coefficient of x will be negative 7, and it's 7x plus negative 7x is also 0. So I just want to make sure that you're aware of various options. So I'm going to divide the bottom equation, every term on both sides, by 2. I'm going to leave the top equation the same, 7x minus 3y equals 8, and divide every term on both sides of the bottom equation by 2. Negative 14x divided by 2 is negative 7x. 6y divided by 2 is positive 3y. And negative 16 divided by 2 is negative 8. And we see that the coefficient of x in the top equation is 7, and the coefficient of x in the bottom equation is negative 7. So I'm going to get an elimination when I add those two equations, because 7x plus negative 7x is 0. Okay, what else do we get? Negative 3y plus 3y. What's that? It's also 0. So not only did the variable x eliminate, the variable y is eliminated. And then on the right-hand side, 8 plus negative 8, what's that equal to? Also 0. Note that 0 plus 0 equals 0. That's true. 0 equals 0 is true. So 0 plus 0 equals 0 is consistent, right? It's a true statement. 0 equals 0 is true. So the system is consistent, but what's going on here? Both variables were eliminated, but we got a true statement. Well, if you look a little closer, you'll notice that the two lines are exactly the same line. If you leave the bottom equation the same here, negative 7x plus 3y equals negative 8. But then multiply every term on both sides of the top equation by negative 1. multiply by -1. Then we get the exact same equation, -7x plus 3y equals -8. So when you graph those two lines, you get the same line. So every point on one line is also a point on the other. So the number of points where the two lines intersect is infinitely many. So this means the system has infinitely many solutions. So there are infinitely many solutions because the two lines are exactly the same line. There are infinitely many solutions to this system. See how that works? Okay, so that's going to happen if you use the addition method, also called the elimination method. If both variables are eliminated and the resulting equation involving just numbers is true, then that tells you that the two lines are the same and there are infinitely many solutions. Right? That's one of the three options for a system of two equations that I mentioned earlier. The three outcomes for a system of two linear equations is there's exactly one solution, like our first example up here, exactly one solution, or there are infinitely many solutions, like the second one. The third one is that there's no solution. If there is no solution, then the two lines are parallel, meaning they have the same slope but different y-intercepts, and they never intersect. That's why there's no solution. Okay, let's look at the next system. This time we have 6x plus y equals -4, and the bottom equation, -48x minus 8y equals -16. So let's use the addition method again. Let's see if we can eliminate the variable y. So if we want to focus on eliminating the variable y, in the top equation, we see that the coefficient of y is +1. And in the bottom equation, the coefficient of y is -8. So if I multiply every term on both sides of the top equation by 8, +8, then the top equation will have a y term 8y. The bottom equation will have a term -8y. And when I add 8y to -8y, I get 0. So that's an elimination. So I'm going to multiply the top equation on every term on both sides by +8. So 8 times 6x is 48x, plus 8 times y is +8y. And then on the right-hand side, 8 times -4 is -32. I'm going to leave the bottom equation the same, -48x minus 8y equals -16. And now we add the two equations together. So what happens when I add the two equations? What's 48x plus negative 48x? 0. 8y plus negative 8y, that's also 0. And the right-hand side, negative 32 plus negative 16. Well, it's not 0, it's negative 48. So what do you think about this equation? 0 plus 0 equals negative 48. It's not true, it's false. So in arithmetic, a word that you could use to describe this equation is inconsistent because it's false. This is false. So what does that tell us about the two lines? We set out to eliminate one of the variables, but in the process, the other variable was also eliminated, and the resulting equation is clearly false. So when we're solving a system of two linear equations using the addition method or the elimination method, well, even if you're using substitution, if you end up with no variables in a false equation involving numbers, that means that the two lines are parallel. The two lines have the same slope, but different y-intercepts. So graphically, they never intersect. So that means the system has no solution. That's one of the three options, or one of the three possibilities for a system of two equations. So another thing that you can do, you can rewrite each equation so that each one is in slope-intercept form. So this top equation, we can solve for y if we just subtract 6x from both sides. So the top equation in slope-intercept form is y equals negative 6x minus 4. And the bottom equation, we can get that into slope-intercept form in two steps. First, add 48x to both sides, so we get negative 8y equals 48x minus 16. And then divide every term on both sides by negative 8. Negative 8y divided by negative 8 is y. 48x divided by negative 8 is negative 6x. And negative 16 divided by negative 8 is positive 2. So here's the system of two equations where each equation is now in slope-intercept form. Right? So make sure that you understand this equation, y equals negative 6x minus 4, is the exact same line as this one, 6x plus y equals negative 4. And the bottom equation, y equals negative 6x plus 2, is the exact same line as negative 48x minus 8y equals negative 16. But when they're in slope-intercept form, you can tell automatically that the lines are parallel. They don't intersect. So the system has no solution because the two lines do not intersect. Right? So parallel lines never intersect. Okay, let's look at some more examples. So let's solve the systems twice, once by substitution and once by addition. Okay, so if I use substitution, it looks to me like the easiest thing to do is solve the top equation for x. So solve the top equation for x. So I get 2x. First thing I do is add 8y to both sides, to 2x equals 8y plus 6, and then divide every term on both sides by 2. And I get x equals 4y plus 3. And then we substitute that into the bottom equation. Replace x in the bottom equation with 4y plus 3. So 2 times x then becomes 2 times 4y plus 3 minus 3y equals negative 9. And then we solve this equation for y. So 2 times 4y is 8y plus 2 times 3 is plus 6 minus 3y equals negative 9. And I'll take this up to here, I guess. So combine like terms, 8y minus 3y is 5y plus 6 equals negative 9. Then subtract 6, we get 5y equals negative 15. Divide both sides by 5, I get y equals negative 3. Then we use this equation, x equals 4y plus 3, to solve for x. So x is 4 times negative 3 plus 3. 4 times negative 3 is negative 12, and negative 12 plus 3 is negative 9. So the x-coordinate is negative 9, and the y-coordinate is negative 3. So the solution using the substitution method is negative 9 for x and negative 3 for y. Okay, that's the substitution method. Let's solve the same system using the addition method. So multiple options. So I think what I'm going to do, I'm going to multiply every term on both sides of the top equation by negative 1. So I'll write a little bit of detail here. Multiply 2x minus 8y equals 6 on both sides. By negative 1. So when I do that, I get negative 2x plus 8y equals negative 6. Then I'm going to leave the bottom equation exactly the same. 2x minus 3y equals negative 9. And then when I add these two equations, the variable x will be eliminated. Negative 2x plus 2x is 0. And 8y plus negative 3y is positive 5y. On the right-hand side, negative 6 plus negative 9 is negative 15. Then divide both sides by 5, we get y equals negative 3. Okay, so we see that that agrees with what we found when we used substitution, y equals negative 3. And we already used substitution to find x when y is -3. But I guess we can do it again. We can pick either of the equations. I'll pick the bottom equation and replace y with -3. So we get 2x minus 3 times -3 equals -9. This is 2x plus 9 equals -9. And subtract 9 from both sides, we get 2x equals -18. And then divide both sides by 2, we get x equals -9. So either way, we get the same result, the ordered pair -9, -3. Okay, in general, you don't have to do it. You don't have to solve a system two different ways. This is just to show you that it doesn't matter which way you choose. Okay, on the next one, I'll illustrate a slightly more sophisticated way to use the substitution. And I mentioned it earlier. So I'm going to solve the top equation for 3y. So if I add 3y to both sides, I get 2x equals 3y plus 5. And then subtract 5 from both sides, I get 2x minus 5 equals 3y. So the reason that I'm just going to solve for 3y is because I see that 3y is in the other equation. So now in the bottom equation, I'm going to replace 3y with what 3y is equal to from the other equation. So instead of plus 3y, I'm going to write plus 2x minus 5 equals -6. And now I can solve for x. -3x plus 2x is -x. Minus 5 equals -6. Add 5 to both sides. I get -x equals -1. And then divide both sides by -1, I get x equals 1. And then to find y, I can use this equation and substitution. So replace x with 1, I get 2 times 1 minus 5 equals 3y. 2 times 1 is 2. 2 minus 5 is -3. And -3 equals 3y. That means when I divide both sides by 3, I get -1 equals y. So the solution is the ordered pair 1 for x and -1 for y. Hey, you don't have to use substitution in that way if you don't want to. I'm going to rewrite the two equations as they appear in the first place. 2x minus 3y equals 5. And the other one, -3x plus 3y equals -6. And use the addition method. Use addition. Okay, so how would you start if you want to use the addition method? We have multiple options, but it looks like the easiest option is to not change anything and just add the two equations. Because in the top equation, I have negative 3y, and in the bottom equation, I have 3y. So if I add those two equations in the original form, the variable y is eliminated. So this is something to notice. I can get an elimination without doing any preliminary work. So just add the two equations. 2x plus negative 3x is negative x. Negative 3y plus 3y is 0. 5 plus negative 6 is negative 1. Then since negative x equals negative 1, x equals positive 1. That's the same result we got in the first case. Okay, we have a minute and a half or so. So do you have a preferred method? Do you think you like the substitution method better or the addition method better? Well, not that you really like either one, but if you had to choose, which one would you pick? In past semesters, students seem to mostly like substitution, but personally, I like the addition method because, I don't know, addition method, eliminating one of the variables just seems to make things easier. Okay, we're just down to a few seconds. So if you use addition, what I would do, I would leave the top equation the same, negative 2x plus 3y equals 1, and then multiply every term on both sides of the bottom equation by positive 3. And then I get 15x minus 3y equals 12. And when I add those two equations, I get an elimination. Negative 2x plus 15x is 13x. 3y plus negative 3y is 0. 1 plus 12 is 13. X equals 1. Okay, we're out of time for today. We'll move on to the next section tomorrow, section 4.2. Tim, right?